We learned how to extract elements based on a given condition. But what if you don't care about the elements, the values themselves, but rather you want to know where these values are occurring in the vector, on which indexes, you want the indexes of these values? Well, there is a way to do this, and this is with the function called find. This function, based on a given condition, will tell you if you have elements that match your conditions and where exactly in your vector they are. First, I'm going to show you how you can use it to find on which indexes you have non-zero elements. So, as you can see here, we have some zeros. We don't care about the zeros. We want the indexes only of the elements that are not zero. How are we going to do this? We're simply going to use the find function. So find some vector. And this is all you need to do. You don't need any additional arguments. As you can see, we get 1, 2, 3, 4, and 5 are missing, and then the rest of the arguments. Now, pay close attention to the values here. These are indexes. These are not the values of the vector. As you can see here, we don't have 10, we don't have 11, 12, or 9. We have 1, 3, 3, 2, 3, 4, 5, and so on. So these are not the values of the vector. These are the indexes that match the condition, and the condition is not equal to 0 in this case. You can also specify how many elements you want to get from that some vector, how many indexes you want to get that are not 0. So if you want the first 5 indexes that are non-zero, you can simply supply a second argument, 5, the number 5, and this will give you only the first 5 indexes that match your conditions. Now you can also use find with a specific condition, so you can say find some vector where the items are equal to 3, for example. And we get the indexes of the elements that are equal to 3. So we have 3, 3, and 3 on the second, third, 4, 5, 6, and the 7th index. 2, 3, 7. The indexes of the number 3. This can also work with any other condition. Now, this is finding non-zero element indexes, or with a specific condition. So find all of them, the first 5, and equal to 3. All right. Now, what if you want to find the indexes of the zeros? How are you going to do this? So, finding 0 element indexes. Again, we're going to use the find function, but we're going to use the not operator, and we're going to give it the vector. So, the not logical operator will reverse whatever condition we have. If you say, if we use it here, it will give us all elements that are not equal to 3. So in this case, when we don't have anything, we're finding all elements that are not equal to 0. And when we say again not, we're saying find all elements that are equal to 0. So let's run it. Let's first suppress these ones. All right, let's run it. And we can see that on the indexes 4 and 5, we have zeros. Just like with this one, we can use an additional argument here, and we maybe want to find the first 0 in our vector. So if we do this, we get 4. Our first 0 is on the 4th index. So find some vector, all zeros. This is the first 0. We know how to find these indexes, but what if we want to get the values behind these indexes? Now, get the values. How are we going to do this? If we want to get all elements that are not equal to 0, so we want to get rid of the zeros, we can do the following. We can say some vector, find some vector, like this, just like we did with the logical expressions, with the logical extraction conditions. Let's run it, and we get the values that we expected. But as you can see here, this is highlighted and it says that if some vector is an indexed variable, performance can be improved using logical indexing instead of find. Logical indexing is what we did earlier. So this is not an efficient way to do it. You can do it, but it's not an efficient way. Much more efficient is, and faster obviously, is to simply say some vector different from 0, which should yield the same result. It does. So if you want to get all of the values that are not equal to 0, using find is not a good way to go. But if you want to get the first 5 elements, for example, that are not equal to 0, then you have no other choice but to use the find function. So find some vector, the first 3 elements. And you'll see that now we don't have highlighting saying that we shouldn't use find. We simply have the highlight saying that we should use a semicolon to suppress the output. Let's run it, and we get the first 3 or the first 5. So we get the first 5 elements that are not equal to 0. And finally, I want to show you the any function, which will tell you if there are any non-zero elements in your vector. So any non-zeros. So if I use any on the sum vector, and we know that the vector is both zeros and non-zeros, and if I run this, we get a 1. We get only one single value. This value, this one, is a Boolean value, and it means true. So we are saying, are there any non-zero elements in the sum vector? The answer is yes. There are non-zero elements, and we have a lot of them. But if I use this function on the second vector that I have here, the zeros vector, any of 0 vector, or run it, we get a 0. So we're asking, are there any non-zero elements in the vector? And the answer is no. The answer is false. And we don't have any non-zero elements. We have only zeros. Similarly, with the not logical operator here, we can say, are there any zeros in the sum vector? Are there any zeros?